In this video, we're going to talk about stretching and compressing functions. When we take our function and we multiply it by a constant, if that constant is greater than 1, what that's going to do is that's going to increase the way our function grows. It's going to grow at a faster rate. So to illustrate this, what I've done is I've created this table. We have our x values. Order of operations says I need to square them. So here's what we get when we square them. And then when I double them, this is going to give me the y values. And we're going to just see what we get here. I am going to double the 4, I get 8. I double the 1, I get 2, 0, 2, and 8. We're going to plot these and we're going to compare them against our parent function, which in this case is y equals x squared, which forms that parabola. So let's plot them and compare. 8 is going to be somewhere up here. My second point has the coordinates -1, 2, which is here. 0, 0, 1, 2, and 2, 8. Now when I connect these with a curved line, you'll notice that my parabola is more narrow. And if I compare them with the lattice points of my parent function, you'll notice that the vertical distance has been doubled. Instead of going over 2 up 4, I now have to go over 2 up 8. My parabola is growing at a faster rate because we have doubled it. Whew, that is not a beautiful parabola. Let's look at the vertical compression. Notice if the number I'm multiplying my function by is less than 1, my function is going to grow at a slower rate. Now the parent function for this graph is y equals x cubed, which makes that graph, but we're going to slow it down. For this example, we are multiplying it by 1/4. So what that's going to do is that's going to take the lattice points for my parent function, which currently are, there we go, oh my gosh, sorry, I'm having technological difficulties here. There we go. Here are my lattice points, and then my next lattice point is up at 8. And we're going to compare them to what we get when we slow it down by 1/4. So, -27 times 1/4, that is going to be -6 3/4. This is going to be 2. This is going to be 1/4, 0, whoops, and these are negative. 1/4, 2, and 6 3/4. Let's plot our points and compare it to our parent function. Okay. -3, I am down to 6 3/4, which is going to be right about there. -2, -2. -1, -1/4. 0, 1/4, 2, 2, and 6 3/4. Now let's connect these with a smooth line. And if you notice, my function is wider. My lattice points are lower than what they would have been otherwise. Instead of having a lattice point right here at 1, 1, it's been slowed down by 1/4. It's actually 1, 1/4. Instead of 2, 8, it's 2, 2. So stretching, when we're stretching, we are multiplying all of our y values by c, and that's going to force it to grow at a faster rate. When we're compressing, we're multiplying our y values by 1/c, and our values are going to grow slower. So that's stretching and compressing. It essentially makes your function more narrow or wider. And that does it. Thank you. Have a great day.